Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into a surprisingly insightful article. Haskell, a great procedural language. Get ready for some mind-bending fun, folks. It's gonna be wild.
Whoa, Haskell. Procedural? I thought it was all about functional purity and monads. This sounds like a challenge to my very understanding of reality.
That's the beauty of it. The article completely flips the script. It argues that Haskell's handling of side effects, often seen as a complex hurdle, actually makes it a fantastic procedural language. Think of it as procedural programming, but with superpowers.
Superpowers? I see. Lay it on me. What's the core argument?
The key is that in Haskell, effectful computations are first-class values. You can store them in variables, lists, you name it, without triggering them immediately. It's like having a recipe for a cake. The recipe itself isn't the cake, but it holds all the instructions.
So you're saying you can build up a whole sequence of actions without actually doing anything until you're ready? That's elegant, and potentially very powerful.
Exactly. The article uses the example of rolling dice. You can create a list of "random RIO" calls, which are side effectful, but no random numbers are generated until you actually execute the list using something like a "do" block, or "sequence A".
But what about the "do" block? Isn't that the magic part?
Not really magic, more like syntactic sugar. The article deconstructs it, showing how it boils down to just two operators. "greater than," "then," and "greater than equals," "bind." It's all about combining and chaining these side effect objects.
Interesting. So it's not some mystical incantation, it's just clever composition of functions. I'm starting to get it.
Precisely. And that's where the real power comes in. Beyond "greater than," and "greater than equals," Haskell provides functions like "pure," "flamap," "lift A2," and "sequence A," to manipulate these side effect objects in incredibly flexible ways. It's like having a whole toolbox of tools to assemble your procedural masterpiece.
Wait, "flamap" works on lists and side effects? That's some serious type class wizardry.
Yeah, that's because they're both functors. "fmap" is a general function that works on any type that's a functor, a type that supports a map operation. It's a beautiful example of Haskell's abstraction capabilities.
So what are the practical advantages? Why would I want to do this in Haskell instead of, say, Python?
Refactorability and discipline. Because side effects are first-class citizens, you can refactor code with impunity. You can pull out chunks of code into functions without accidentally triggering side effects prematurely. It's a huge win for maintainability.
And the discipline part?
Haskell's structured approach to side effects helps prevent accidental side effects and interaction bugs. It forces you to think carefully about how your actions interact. It's like having a safety net built into the language itself.
I see. So it's not just about doing things procedurally, it's about doing them safely and elegantly. This is starting to sound really appealing.
Absolutely. The article goes even further, exploring functions like "traverse" and "sequence A" for working with collections of side effects, and even touches on using the "state" monad for managing mutable state in a controlled way. It's a whole ecosystem of tools for building complex procedural logic with the safety and elegance of Haskell.
This is amazing. I never thought I'd hear Haskell described as a great procedural language, but the article makes a compelling case. It's like discovering a hidden dimension to a language I thought I knew.
That's the magic of Haskell, my friend. It's a language that rewards deep understanding and clever application. And this article is a fantastic introduction to its procedural side. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the surprisingly procedural world of Haskell. Until next time, happy coding.
Bye-bye.